with this warm-up problem, you don't have this one, but could someone talk me through this real quick? Okay. So this is a pretty easy one, but just to review the concepts, sorry. We need 3x to become exactly 3x squared. So we need to multiply by an x, and I don't care where you write that, okay? Then x gets distributed to both of these terms. So x times 3x, x times negative 2. Now, what's the trick that everybody forgets here? Okay, we're subtracting both of those terms, not just this one, but also this one. So if we change the sign, now we can add. So we get, right, 6x minus 12. Okay. Now we need something that will make 6x out of this 3x. So we need to multiply by a positive 2. Distributing that to both terms will be 6x minus 4. Then if we subtract again, we're adding the opposite here, and we end up with a remainder of negative 8. Can anybody tell me how to write that answer as a fraction? Okay. So our answer was x plus 2, and we put the remainder over the divisor. Okay, yes. No, that would be fine. The issue, okay, is if your answer was negative 3x plus 5 over x squared minus 2x plus 8, okay? If you moved the negative out here and made that positive, that would imply that both the 3x and the 5 were negative. So it's better just to write plus and leave whatever's up here, okay? The only time it would matter, Scott, is if you had a binomial up there, okay? One more thing real quick. If we're checking this, okay, to do the check on this, let me just maybe erase this and give myself a little space. You would say, I got x plus 2, so I need to multiply it by the divisor, 3x minus 2, and then I need to add the remainder. So if I foiled this together, I'd get 3x squared minus 2x plus 6x minus 4 minus 8, which would be 3x squared plus 4x minus 12, which got me back to here. Okay? Just to show you how the check works. Now, if it's a more complicated problem, that becomes a lot more painful to check as well. But all right, so that's what we did yesterday. We also talked about synthetic division, and that's kind of where we're going to start the lesson today. On the back of worksheet, is this 5, guys? So 5b talks about the remainder theorem. The remainder theorem says that when you have a linear divisor, okay, you're dividing by x minus 3 or x plus 8 or something. The remainder that you get will always be the same thing as what you would get by putting the 0 into the function. All right, let me talk through what that's saying, okay? If we are doing, I'm going to come back to that. Okay, just kidding. Let me make up an example. Well, let's go back here. Let's just do the one we're doing because I don't want to waste time making one up. Nope, that wasn't a linear divisor. Let's go back to the beginning yesterday. And then we'll do some more today. But at the beginning yesterday, when we did the first example, we divided by x plus 1, and we got a remainder of negative 5. Does everybody see where I'm at? Okay. You could have predicted that remainder by taking the 0 of this negative 1 and plugging it into this function. So f of negative 1 would have been 3 times negative 1 to the third minus 2 times negative 1 minus 4. So negative 1 to the third is negative 1 times 3 would be negative 3. Negative 2 times negative 1 is plus 2 minus 4. This would be negative 1 minus 4 more is negative 5. So by trying the 0 into the function, I knew it wasn't going to come out even, that it was going to have a remainder of negative 5. So that's a check, but it is also a predictor of whether it's going to go in evenly or not. The same is true here. Everybody see when we put this in, we got a remainder of negative 5 when we did it synthetically. So we could have put negative 1 again into the function and predicted what the remainder was going to be. The book suggests that this is a good use for that. They say if this was the polynomial function that predicted the number of tickets sold during a game, at a high school football season where X is the number of games played. So they want to know how many tickets were sold during the 12th game. We could put a 12 in here and type 12 to the third minus 12 times 12 squared plus 48 times 12 plus 74 to figure out the answer. Or you could do synthetic division, putting a 12 in. It just so happens synthetic division is really short for this one. Bring down the 1 times 12 is 12. Add it to this negative 12, it's 0. 12 times 0 is 0. 48 and 0 is 48. Multiply, add, you get 650. So you could put it in, which is what they did down here, and get 650, or you could do synthetic division. I probably would have typed it in. All right. If when you do this, if you put this value into the function and you get 0, that means dividing it in should come out exactly even. There should be no remainder. So the factor theorem says if you divide it in and you get a 0, then the other direction is also true, that if you were to substitute it in and get a 0, that it should come out with a remainder of 0. Let's try this question. You have this. Okay, enough sleeping. Everybody awake? Okay, it says determine whether x minus 2 is a factor of this polynomial. We can substitute it in. So somebody type 2 times 2 to the third plus 5 times 2 squared minus 14 times 2 minus 8. And see what we get. I'll try it. Yeah, I think that's coming out 0. Okay. So is x minus 2 going to be a factor of this? Meaning it goes in evenly. What is the 0 telling us? The remainder is 0. Whoa, I can't spell. The remainder will be 0. So it should be a factor. So let's try it by division to prove that. It says to do it 2 ways here. We need to remember how to do synthetic division. What goes into the box here is the 0. So x minus 2 is the factor, so 2 is the 0. The coefficients across the top, do we need any placeholders? We have a 2x cubed, a 5x squared, a negative 14x, and a constant of negative 8. Okay, talk me through it. 2 times 2 is 4. Add. Multiply. Add. Multiply. Okay, add, and we get a remainder of 0. Now, the remainder of 0 means that this went in evenly. So if we were factoring this is where we're going with this today. X minus 2 is a factor. What's left over? Can you remember? This is called the depressed polynomial down here. Okay, we have a 0 is the remainder. This is a constant x squared. So we have 2x squared plus 9x plus 4. I didn't know how to factor this up here. But once I found that it had a 0 here, and I factored it, could I now factor the remaining part? I know how to factor things with x squareds, right? 2x 4 would be 8. I think that's right. So we were able to completely factor it based on the fact that we found one of the factors. All right. Part B says, how could you check your answer on number 4? This is number 4 on the front side. So we did this problem yesterday. I just took a picture of what we did yesterday and put it on this slide. How could we check that we did this right? Yes, if we went back to the original polynomial and we found f of 1, because that's what we were dividing by, the 0 was 1, it should come out to be what? The remainder. So if I put a 1 in here, 1 to the 4th minus 3 times 1 squared plus 12 would be 1 minus 3 plus 12 is negative 2 plus 12 is 10. And that should be our remainder. Is that what it turned out? Okay. Trying to tie those two ideas in your head. You can do a problem either way. If I ask you what's the remainder and that's all I asked, you could do it by direct substitution. If I asked you a value of a function, you could, in theory, do the synthetic division and just find the remainder. If you have a calculator in your hand, I'm not quite sure why that's better, but all right. I'm going to skip this example, I think, and we're going to do this one together. You have number 7. Is that the next thing on your paper? Okay. 6 was? Did I skip something? Am I missing a slide, or is it just numbered differently? Okay. So let's talk through number 6. I don't have it for some reason, but it just says, is x minus 4 a factor of 2x cubed minus 3x squared minus 6x plus 2? Why does it say c equals 4? Is that what that says? Okay, so yeah, we need to plug a 4 in if we want to predict. So someone could be doing that, or we could be doing synthetic division to decide if it's a factor. This might be smaller numbers that I could do in my head, but maybe not. I got 58. Did anybody type it in the calculator? You got 58? So this came out 58 as well. So the question is it a factor? No, because there's a remainder, right? The remainder equals 58. That's just, you can just write no, I don't care. I'm just reminding you why. And that's supposed to say the remainder is 58. I just scribbled. All right, now we'll talk about 7. Use the factor theorem to determine if the binomials given are factors. Use the binomials that are factors to write a factored form. So this one only gives us one binomial, x plus 5. Okay, you want to use synthetic division or substitution? Does it say? Okay, you guys can do substitution, so find f of negative 5. The problem, if it is a factor, we're going to have to do the substitution anyway. I'm sorry, do the division anyway. So I'm going to go ahead and start that. Does anybody know why we're going to have to do it anyway if it is a factor? Because we need that depressed polynomial at the end. Okay? I'm hoping it's a factor, so I'm going to bring this down, multiply, add. Multiply negative 5 times negative 7 is 35, add is 6, negative 5 times 6 is negative 30, and I get 0. Did anybody do this substitution and get 0? Didn't work when you put in negative 5? Negative 5 cubed would be negative 125. Negative 5 squared would be 25 times negative 2 should be negative 50. 29 times 5, 295. And if it was a negative 5 and a negative 29, it should be plus 295. Okay, yep. Can't multiply. Well, if that's the first mistake I made trying to do all that in my head. What was 29 times 5? That looks a little bit better because this would be a negative 175 and a positive 175. So you do get 0 out of all that. Still not getting it when you do it on the calculator? It would be negative 5 cubed minus 2 negative 5 squared minus 29 times negative 5 plus 30. Easy to make a sign mistake when you're typing that in. Did Savannah find your mistake? No? Okay. I did the division, it came out 0. So x minus, or negative 5 is a 0. What's the factor, guys? Be careful. I almost wrote it wrong. What's the factor? X plus 5. Ugh. Okay, x plus 5 is the factor. What's the rest of it? After we divided by that, we were left with, okay, can we factor that so that we have a completely factored polynomial? How would this factor? It's got to multiply to make 6, so how about minus 6 and minus 1? Okay. Did it ever work, Savannah? Did you give up? Okay. All right, guys, this is a horrible question. No, it's not. Do you have this one? I'm sorry, Em. This is an extra example. This is not a horrible one. Just watch, because I want you to see. Okay. This is an introduction. I was talking about another question. This is an introduction to what's called successive division. Okay. I'm going to divide this in by synthetic division. What goes in the box? Talk me through this quickly. And across the top? No placeholders, right? Okay, bring down the 2 times negative 4 is added times negative 4. Added is negative 5. Okay. Okay. We want to continue with this. Successive means one right after the other. We don't want to go back to the original polynomial because this was successful. We would want to now divide it by this of x minus 5, whoops, which makes the 0 what? Okay, we're going to keep going. We're going to use the leftovers here, and we're going to use 5 as the next 0. Bring this down. 5 times 2, add, multiply. Okay, we just completely factored this. What are the factors? Okay, this is a constant and a 1, so 2x plus 1, and x plus 4, and x minus 5, okay? Any questions about what we did? But the important thing is we had to do one division after the other to keep dividing it out. All right, the question I want us to do is this number 8, but it says graph first. So can you graph this problem? I think I tried it on this calculator. Yes, make sure you turn the plot off at the top up here. Make sure plot 1 is turned off. That's going to be an issue on the next quiz for some of you. I can never type these in. This is like the most time-consuming part for me. All right, I don't know if I got it in right or not, but if I go to Zoom 6, get kind of a mess. I should probably find a better window. But if what I'm really concerned about is the zeros, how could I test some of those values that it looks like are zeros? You could find zeros using left and right bound, but it's much faster to just guess. If I go to trace, what do you want me to test? What does it look like is a zero maybe? My window goes -10 to 10. What do you think it might be crossing right here? -2 maybe? -2 shows up as a zero. What about -3? It's a zero. Okay, up above in the question, it asks, is x minus 1 a factor? So how do we test that? Yeah, test 1. Is 1 a zero? Go trace 1, and we get out what? Okay, that's not going to be a zero. Was -2 a zero? And is x minus 2 or +2 a zero? Anybody type that one? Trace 2. 2, enter. It says at the bottom it's a zero, right? Okay. We're supposed to now factor this. We don't want to use 1 because it isn't a zero. We're going to start with one of these. Anybody care which one you start with? So you want to put in the box first a +2, which means this is our first factor, right? Okay, do we need anything across the top? Placeholders, that's what I'm trying to say. 3, 8, -15, -32, and 12. All right. Anybody want to try this in their head? Can use a calculator, but 3 times 2 would be 6. Added is 14 times 2 would be, added would be 13 times 2 is, added is -6 times 2 is -12. So it's got to come out 0. We predicted it on the graph, right? It was a 0. So if your remainder is not 0, you made a mistake. All right. Successive division means we don't go back to the original polynomial. We keep going. With this newly reduced one, what are we going to try now? We did this one. We said this also works, so we're going to do a -2. Bring down the 3. 8, -16, -3 times -2 is +6, 0. All right, we can now completely factor this, I think. Why? The things. What do we know right now? We've already tried. Yeah, we did +2 first, so I'm going to write that one just so people looking at the notes aren't confused. Then we did -2, which would be x plus 2. Then what's left is what polynomial down here? Good job. So we want to know, does that factor further? Let's see, if we had a 3x and a 3 back here, and an x and a 1, so we had 9. that was positive and 1 that was negative. Would that work? 3x squared plus 9x minus 1x minus 3 would be this. Okay. How could I check that that's true? If I went back to my graph, negative 3 should work. I think we already tried that once, didn't we? What else did we get the other 0 to be? Exactly 3x minus 1 makes the 0 what though? 1/3. So if we went trace 1 divided by 3, it should come out exactly 0. Okay. All right. So this slide just ties all the vocabulary together. It says if the remainder, when you do synthetic division, okay, if you can predict the remainder by subbing in the 0. If the remainder is 0, then it is a factor. If the remainder is 0, that means it's an x-intercept and a solution when this function is set equal to 0. Remember, 0, x-intercept, root, solution, they're all the same business. All right, if you started last night's homework, grab the sheets. If you did not, grab a sheet of notebook paper real fast. Because on the homework assignment, it said this. This is what it says. So we now are going to do 53 and 59 together, okay? By the fact that you're all going for a sheet of notebook paper, that means nobody started this last night? Nice. You're supposed to have done these 4 questions, 18, 16, 19, and 20 so far. Okay. We're going to do 53 and 59 together quick. First, we're going to do 59 for what, and let's do 53 first. It's fine. So 53 says, find the value of k so that the remainder will be 0. Anybody have a thought? What can we do with 2? If the remainder is 0, when we put in a 2, we should get out what? 0. Good job. So if I put in a 2 up here, it'll say 2 cubed minus, I don't know what k is yet, but k times 2 squared plus 2 times 2 minus 4 should turn out to be what? 0. So can you solve that now? 8 minus 4k plus 4 minus 4 equals 0. What does that make k? I'm going to add the 4k over the other side just because I like positives. But either way, k should turn out to be positive 2. Should be positive 2. Do you have to do another one of those? Yeah, 55 maybe is like that. Okay. Now we're going to try 59. This is like several problems on the homework, only this one's miserable and the ones on the homework are easier than this, okay? So if we can do the miserable one together, you can do the easier ones. Got it? So the question says, use the graph and synthetic division to completely factor this polynomial. So you have 30, can someone shut the door, please? You have 30 seconds to try to type this in correctly. You want me to read it to you? Negative 6, I'm sorry, it's positive 6x to the 5th, 6x to the 5th, plus 13x to the 4th, right arrow, minus 153x to the 3rd, Right arrow, that's what I always forget. I get up in that exponent. Plus 54x squared plus 724x minus 840. I put it in 4 times before I got it right in the other class. Minus 840. Yeah, the calculator was in the way. Okay. Now, if you do a Zoom standard, anybody think they can pick any of the zeros? -4, you think? So if I do trace -4. Nope, at -4, it's 4,000. Okay. Can I suggest try changing the window to -500 to 500 for the y? Go to y equals, leave your x's, but go down and change the y to -500 for the min and +500 for the max. Yeah, it's still not good, but any better ideas? No, don't change the window again. I just want to know where it's crossing the x. Can you make a guess? That's because you have a stat plot on. You need to go up arrow and turn the plot off. Can you check that, Malia? Anybody else having trouble? Is it still not working? Go to graph. Okay. I need somebody to guess where they think one of these is. -6. Whoops, I got to do trace first. Trace -6 is a 0. Okay. What else? -2.5 is a 0. Okay. +2. I didn't think +2 was a 0, but it turns out that it is. Okay. Now, how many zeros do we need to find on the graph so that we can divide these in? If we start with what degree? Degree 5. What do you know how to factor? A degree? Mostly 2, right? X squared you can factor on your own? Sometimes an x fourth, depending how it's set up. But we can factor for sure if we get down to an x squared, if it factors. So we need to find 3 on the calculator. What 3 did you find? -6, be careful. -2.5 and 2. All right. We're going to start successive divisions. Which one do you want to do first? The -6? Okay. Gonna need a calculator, I think. Okay, -6 times 6 is -36. Plus 13, anybody? -23 times -6. Maybe 138? Yep, totally wrong. Sometimes 6 times, what? I don't think that's right. Okay. I thought I was close. 138. -153 plus 138. What? Oh, I thought you said 50. My bad. -6 times -15 is +90. added to 54 is 144 times negative 6. $724 and negative 864 is negative 140. That's a 4, sorry. And negative 6 times negative 140 is 840. Okay. Successive division. We need to pick another one that works and keep going. Negative 2.5. I promise the ones on the homework aren't this bad. That's why we're doing this one together. Negative 2.5 times 6 is no 15. Okay. Negative 23 and negative 15 is negative 38. Negative 2.5 times negative 38. Hope someone's checking me. 95 would be positive 80 times negative 2.5, negative 120 maybe? Yep, just kidding. That'd be 1.5, not 2.5. What was it? 2? Thank you. So 56 maybe, negative, times negative 2.5. 140, good. Otherwise we're in trouble. Okay, one more. Positive 2. I promise none of them on the homework are near this hard. Bring down the 6. 2 times 6 is 12. Negative 38 plus 12 is negative 26. Times 2 is negative 56. 80 minus 52. I'm just kidding, right? This should be 52. I multiplied wrong. Is 28. 2 times 28 is positive 56, which makes this 0. Okay. The point of this was we were supposed to factor. Okay, what do you know so far? You have an x plus 6 that went in, an x minus 2.5, no plus 2.5. What about this one? X minus 2. What's left over here? 6x squared minus 26x plus 28. What could we take out of all those? A 2? I'm going to take a 2 out and put it out front. That'll leave a 3x squared minus 13x plus 14. Okay, how are we going to factor that? There's not an x on the 14. We can't take out an x. 3x and 1x. Factors of 14. Okay. And they're both minus. I don't know if I can move this. What's wrong? I took out a 2, and we got that. And then we factored that. And we got what? A 3x minus 7, guys. And an x minus 2. What do you notice right here, real quick? There's 2 of those. What should the graph be doing at 2? What is 7/3? 2 1/3. Okay, I changed the window on this. Look what happens. If you zoom in enough, there is a bounce to 2 and then it crosses at 2 1/3. My window there was super tiny, like 0 to 5 for the x and negative 10 to 10 for the y. If you zoom in enough, this graph is actually doing a tiny little bounce there, and I predicted that by the fact that x minus 2 was a factor twice. All right, tying a bunch of stuff together there. Yours are not that hard, I promise. These are the 5 you have to do tonight. 31, 41, 55, 57, and 58. I'm not done. We have a couple minutes. I want to talk about one theorem on the top of worksheet 6A. Yeah, absolutely. It's in the same place on the check. All right. One theorem. The rational zero theorem says that the list of all possible rational zeros. Rational means nice, pretty whole numbers, which can include negative numbers, which should be integers. Rational also includes anything that can be written as a fraction. So terminating and repeating decimals, fractions, integers, all those are rational. Every polynomial function, okay, that has any real solutions, we can determine if there's any rational solutions using this theorem. It says you take, and this is what it looks like on your notes. It says if you want a list of all possible rational zeros, I think this is right off your notes, what you're going to do is find all the factors of the constant term and put those on top, and all the factors of the leading coefficient and put those on the bottom. So we're going to do one example before you leave. Not even up there. We'll go back and cover the examples on your notes. I just want to do this one. Okay, I need all the factors of 36. Out loud, what goes into 36? 1, 2, 3, 4, 6, 9, 2 times 18, and 1 times, okay. The bottom is the factors of the leading coefficient. What goes into 2? 1 or 2, right? So you can't leave the answer like this. You have to tell me what that means. All of those numbers over 1 would be written like this. Ooh, okay. If I put all those numbers over 2, which ones are not on my list? Is 1 over 2 on my list yet? No. Is 2 over 2 already on my list? 2 over 2 is 1, right? It's already on the list. 3 over 2, not on the list. 4 over 2. 6 over 2. 9 over 2. All the rest of these are already on the list. All of those numbers, back in the day before I had a graphing calculator, I had to try all those numbers until I found zeros that worked. You will have to generate that list, and then you will get to try them on your calculator and look at the graph, okay? So tomorrow we're going to finish this lesson 2.4. Tonight, do those 5 questions. Or the 9 questions if you didn't do last night's homework.